For example 3, we're going to go through the process of being given a function and then finding its inverse function. The very first step is to exchange where it says f of x and write y in its place. So I'll write y equals 1/3 the quantity x minus 5. Then we're going to interchange x and y. Everywhere that I see x, I'll put y, and everywhere I see y, I'll put x. So let's rewrite this as x equals 1/3 y minus 5. All right, now what we're going to do is solve for y. We want to get y by itself and everything else on the other side. I'm going to start by multiplying both sides by 3 to clear that fraction. I'm going to multiply by 3 here on both sides. I don't want that to be this color. There we go. And so I'll get 3x is equal to, this 3 and this 1/3 are going to cancel here on the right. So I'll have y minus 5. And then we'll add 5 to both sides. And we're getting that 3x plus 5 is equal to y. And then the final step is to rewrite y as f prime of x, or sorry, f inverse of x. So these are the inverse functions. F inverse of x is 3x plus 5. Let's go take a look at these graphs in Desmos to see how they compare to one another. So for the example that we just did, the original function we were given was this one, 1/3 times the quantity x minus 5, and we can see that it's a line. I have this line, the dashed green line is the line y equals x, because when we show the inverse function, which we got 3x plus 5, those two functions should be reflections across the line y equals x, because part of the process we used was to exchange those two variables. And you can see that this looks like it's a reflection across the green dashed line. Let's go back and look at another example. For example B, we're starting with the function f of x equals 2 minus the square root of x. Our first step is to write y in the place of f of x, and then we will interchange x and y. Now we want to solve for y, get y by itself and everything else on the other side. I'm going to subtract 2 from both sides. And then I'm going to multiply both sides by a negative just to get rid of this negative in front of the square root there. So this will be square root of y equals, that'll be negative x plus 2, or let's just write this as 2 minus x. Okay. Now I'm going to square both sides of this equation to get rid of that square root sign. On the left, we'll get 4 minus 4x plus x squared, and on the right, we'll get y. Just rearranging this. And then instead of y, now what we write is f inverse of x. Let's take a look at this in Desmos, because this is one that we need to maybe proceed with caution. My final answer that I'm getting is a quadratic, and I know that quadratics look like this, which is not a one-to-one function. That tells me that I might need to restrict the domain to make sure that I'm getting the correct output that I want from my inverse function. So the original function that we had was the 2 minus square root of x, and we can see that it looks like this. It's a square root that's shifted up by 2 because of the 2 here, and then the negative is reflecting it, so it's growing downward rather than up. The function that we just found potentially as the inverse is this one. But we can see that this is not a one-to-one function, and it doesn't exactly look like it's a reflection across the line y equals x. So what I'm going to do is I'm going to just take the left-hand side of the graph. I'm going to take only the x values that are less than 2. So that way, by restricting the domain, when I reflect it, I can see that this does in fact give me the blue graph that I have. So I'm going to go back to our original here, and we're going to say that yes, this is our inverse function, but we're also going to put the caveat that our x's need to be less than or equal to -2. Let's look at one more example. All right, we'll start this process by writing y equals 3 over x minus 2, and then we'll interchange x and y. Next, we're going to try to get y by itself. So I am going to multiply both sides by y minus 2 so that I can clear that fraction on the right-hand side. So let's see, we have y minus 2 times x, and then that equals 3. Now I will divide both sides by x. So y minus 2 equals 3 over x, and then we'll add 2 to both sides. And we get y equals 3 over x plus 2, or f inverse of x equals 3 over x plus 2. Let's go back to Desmos again and see how these graphs look. So that is this third example. Here's our original function. This is a function that's got asymptotes. We're going to talk about some of these functions next week. So the blue graph is our original. There are 2 different components to it. And then here's the red graph. So if you just look at this part over here on the right, you can see that these 2 are reflected across the green dashed line. And then look at the part down here separately. These also are reflected across that line.